we're going to evaluate the integral from 1 to 2 for the square root of x squared minus 1 over x dx. In order to evaluate this integral, we're going to use trig substitution. You can see that x squared minus 1 under the square root is equivalent to the expression the square root of x squared minus a squared equals secant theta. Using this formula, we can substitute secant theta in for x. So letting x equal secant theta, and then dx would then equal secant theta tangent theta d theta. Now we can already tell that it's going to be a little hard to evaluate any trig function at an upper and lower bound of 1 and 2 without a calculator. So in order to make these bounds a little easier to work with, we're going to plug in 1 and 2 for x and get our new bounds. So when we let x equal 1, we get 1 is equal to secant theta, which then would equal 1 is equal to 1 over cosine theta. And then you just multiply by cosine on both sides, just solving like an equation. And then you would get cosine of theta equals 1. So at what value of theta does cosine equal 1? That would be 0. So this 0 would now be our lower bound. Now when we plug in x equals 2, which is our old upper bound, we have 2 equals secant theta, which then would be 2 is equal to 1 over cosine theta. Doing the same thing, we just multiply by cosine theta on both sides, which now would give us 2 cosine theta is equal to 1. Divide by 2. At what value of theta does cosine equal 1/2? And that is pi over 3, which is now our new upper bound. So using all this information here, we now get the integral from 0 to pi over 3, and plugging in secant theta for x, we get the square root of secant squared theta minus 1 over secant theta, and then dx is now secant theta tangent theta d theta. So the next step would be just to simplify this further. So if we look at secant squared theta minus 1, using the Pythagorean identity of secant squared theta minus 1 would be equal to tangent squared theta, we can see that we can plug in tangent squared theta for this part of the expression. So using that identity, we have the integral from 0 to pi over 3 of the square root of tangent squared theta over secant theta times secant theta tangent theta d theta. Okay, so simplifying even further, we can see that taking the square root of a square cancels out. So now we have the integral from 0 to pi over 3 of tangent theta over secant theta times secant theta tangent theta d theta. Now if we look at this, we can cancel out the secants, and then tangent theta multiplied by tangent theta d theta would give you the integral from 0 to pi over 3 of tangent squared theta d theta. Now, in order to integrate this, we would need to find the antiderivative for tangent squared theta, but because that's a little bit difficult to find, but we know that tangent squared theta is equal to secant squared theta minus 1, using that Pythagorean identity that we used earlier, it would make this much easier to integrate. So changing that, we would have the integral from 0 to pi over 3, and this would be secant squared theta minus 1 d theta, again using that identity that we used earlier. Now this is much easier to integrate. So this would then equal the antiderivative of secant squared theta is just tangent theta, and the antiderivative of 1 is just theta. Now we're evaluating this at the bounds 0 and pi over 3. So evaluating this expression, we have tangent of pi over 3 minus pi over 3, and we're using the upper bound first, minus tangent of 0 minus 0. Now looking at this, we can see that the tangent of pi over 3, well, we can just break that down actually to make it easier to solve by using sine and cosine. So the sine of pi over 3 over the cosine of pi over 3 minus pi over 3. Now, the coordinates for pi over 3 are actually right over here. 1/2 root 3 over 2. And this would be cosine, and this would be sine. So, writing that out, we would see that the sine of pi over 3 is root 3 over 2 divided by the sine of, or the cosine of pi over 3, which is 1/2. And then you just, of course, multiply by the reciprocal, and then the 2's cancel out, and then you just have root 3 minus pi over 3. And then tangent of 0 would just be 0, of course, because the sine of 0 is 0. The cosine of 0 is 1. That just equals 0. Minus 0, of course, is 0, so we don't have to worry about this side. And our answer would then just be root 3 minus pi over 3.